switching mode regulators. DC choppers can be used as switching mode regulators to convert an unregulated DC voltage to a regulated DC voltage. The regulation is normally achieved by pulse width modulation at a fixed frequency, and the switching devices is normally a power BJT, MOSFET or IGBT. This is the block diagram which shows all the elements to make a switching mode regulator. When you compare the output voltage with the reference voltage, you will be getting some error voltage that should be amplified to get the control voltage. And this control voltage VC can be compared with the sawtooth voltage VR to generate PWM control signal for the DC chopper. We can notice in the topic of DC chopper with resistive load, the output is discontinuous and contains harmonics. The ripple content is normally reduced by LC filters. You can refer the topic DC choppers with resistive load. The link is given in the description. Now you can observe this is the VC which is coming to the controlling unit, and this is the VR, a sawtooth voltage, and this two is compared to get the gate signal to the DC chopper. This is the generated pulse width modulated signal for the DC chopper. The switching regulators are commonly available as integrated circuits. The designer can select the switching frequency by choosing the values of R and C of frequency oscillator. As a thumb rule, to maximize efficiency, the minimum oscillation period should be about 100 times larger than transistor switching time. This limitation is due to the switching losses in the transistor. The transistor switching losses increases with the switching frequency. As the switching frequency increases, the losses will increase. As a result, the efficiency will decrease. In addition to this, the core losses of an inductor limits the high frequency operation. If a transistor switching time, let it be 0.5 microseconds, and oscillator period, let it be 50 microseconds, then the maximum oscillator frequency equal to 100 times of translator switching time, that is 0.5 microseconds. This is time, so frequency is 1 by the time. This will give us 20 kHz. Now there are four basic switching regulators. First one, buck regulator. The second one, boost regulator. Third one, buck boost regulator. And fourth one, Cook regulator.